All right, textbooks open to page 136 and unit numbers 44 through 61, practicing with signed numbers. We've been doing a lot with signed numbers over the last few lessons, and we are going to take a quiz here in just a moment over these. I think I mentioned that in our last lesson. Remember that when you multiply signed numbers, if the signs are the same, positive. If the signs are different, negative. When you multiply signed numbers, if the signs are the same,
do the opposite.
Positive. And if the signs are different, negative. If you divide signed numbers and the signs are the same, positive. If the signs are different, negative. If you add signed numbers and the signs are the same, add and keep the sign. Okay, when you add signed numbers, if the signs are the same,
add and keep the sign.
and if the signs are different,
subtract and choose the reciprocal number.
subtract and choose the sign of the greater absolute value. So if the signs are different, class,
subtract and choose the sign of the greater absolute value.
good. But if you add like signs,
Keep the sign.
add and keep the sign. Now, if it says to subtract, no. What do we do, class?
Add
Add the inverse, which means we go right back here. So once we've added the inverse, if the signs are different,
choose the greater value sign.
subtract and choose the sign of the greater absolute value. But if the signs are the same,
Add and keep the sign.
add and keep the sign. Let's see how we did on numbers 44 through 61. Number 44, what'd you get for your answer, Glenn? Oh, Glenn. Signs are the same. Add and keep the sign. Add and keep the sign.
He said negative 12 first time.
Yeah.
You said negative 12?
Yeah.
That came out to sound like negative 4 to me. Negative 12 is our answer. You got to speak up, boy. Can't hear you. You did say negative 4. See, she lies to me.
Yeah,
All
I
right.
was negative 4.
You have just lost favorite student status. All right. So, Glenn, it should have been what? Negative 12 negative. Negative 12. It's like people who put dollar signs after the number. No. Negative comes before the numbers, just like dollar sign. All right, so for redemption, Glenn, number 45. Negative 15. There we go. That time we subtract, keep the sign of the greater. Number 46, we can't do it that way. We're going to have to add the inverse. But then what do we get, Evie?
Positive 38.
Positive 38. Number 47, we don't do that. We're going to have to change it up a little bit. What do we end up getting for our answer, Aubrey?
94.
Positive 94. Number 48, we're good as long as you think of that as positive 12, negative 18, which gives you, Lexi,
Negative 6.
negative 6. Number 49, as long as you think of that as negative 21, negative 8, we're good. And what do we get? Danielle?
Negative 21.
Oh, Danielle. Signs are the same. They're both negatives.
Positive 21.
No, Danielle. If the signs are the same, add and keep the sign. Just like here, negative 7, negative 5, negative 12. So negative 21, negative 8,
37.
negative 37. That poster's not going to be up for the quiz, Danielle.
Why do you keep saying 21?
Negative 29.
You keep saying 21.
Do I? I don't know. I got Glenn disease. All right. Negative 29, negative 8, negative 37. Our answer for number 49. What?
You said dyslexic.
I said I got Glenn
No,
disease.
I said that.
You said I'm dyslexic, I'm dyslexic, whatever.
No, that's the Glenn disease.
That's the Glenn disease.
Yeah, that's
Okay.
what I was saying the Glenn disease was.
All right, anyway. Okay, questions on 44 through 49. Adding signed numbers. Know the rules. Do them. Follow the rules. Numbers 50 to 55, multiplication, division. On 50 to 55, same signs positive, opposite signs negative. It's that easy. So on number 50, Michael? 72. Number 51, Hayden? 88. Positive. 88 we might add, though the positive could certainly be left understood. Number 52, speaking of understood, or rather misunderstood, Glenn? Yes, Glenn. Negative 33 is correct. Number 53, Evie? Positive 11. Number 54, Lexi?
Negative 5.
Negative 5. Number 55, Aubrey?
Negative 2.
Negative 2. Questions on 50 to 55. All right, number 56. We got lots of factors. And so we don't want to do the whole same sign positive, opposite sign negative. What's the rule we follow when there's lots of factors here, Michael?
We multiply the negatives first.
No, that's what we do with multiple add-ins. Danielle?
You look at how many negatives there are, and if there are if there's like 3 or something, then it would be negative. But if there's like 2 or 4 or 6 or however many, then it would be positive. The
Okay,
answer-
so odd number, you look at just the
Yeah.
negatives, right? If there's an odd number of negatives, you get a negative. Even number of negatives, you get a positive. So how many negatives are in number 56, class?
3.
3, that's an odd number, so I know my answer is going to be
Negative.
negative. And you ignore the ones because they're a waste of your time. You got a 3 and a 2, which is 6, times 7 is
42.
42, so your answer is?
Negative 42.
Negative 42. Now on number 57, Michael, here we've got multiple addends. And when there's multiple addends, my suggestion was to start by adding together all the
Negative.
negatives and then add together all the
Positive.
and then put those together, so only one time do you have opposite signs and have to subtract. What do we get for answer on 57, Michael?
7.
Negative 7. You get all your negatives together for negative 15. You only have the single positive 8 and go from there. Number 58, there's one little number in there that makes the whole thing really easy, Hayden.
0.
So what's our answer?
0.
0. You would look, perhaps, if you notice the signs first, you'd be like, oh, it's going to be a positive because there's 2 negatives, but it don't matter. There's a 0, and 0 doesn't have a sign, positive or negative. Number 59, basic order of operations here. When you take care of parentheses first, then the exponent, then multiply and divide, and then finally finish with the single subtraction. What do we end up with for our answer on number 59? Aubrey.
24.
Really close. Glenn?
23.
23, our answer. Check your addition first to get a 6 in the parentheses. I'm also going to go ahead and square the 3 to get a 9. And then we can do the multiplication and the division in the same step. I think, Aubrey, you had 24, but I think somebody thought 9 divided by 9 is 0 instead of 1. Am I right? And then the 24 minus 1 is 23. Number 60, we've got an exponent and parentheses within the brackets, so multi-step here. What did you end up with for your answer for redemption, Aubrey?
34.
34 this time. Good. We're going to square the 4 to get a 16. We're going to add the 2 and the 4 to get a 6 since they were in parentheses within the brackets. Then the brackets simplify to 16 minus 6, which is, class? 10. And since the 2 is up against the bracket, that means
20.
multiplication, which I have to do the multiplication here before I can do addition. So I will get 20 plus the 14. Not adding first to get 16 times 10 is 160, but multiplying to get 20 plus the 14 gives the 34. Good job, Aubrey. Number 61, what's our grouping symbol, class?
Division.
The fraction bar, which means division, but you have to figure it to a single number in the top and a single number in the bottom first. What do you get for your answer there, Evie? 1. Good. You're going to raise 2 to the 4th power, which is a 16. Subtract that from the 25. Of course, in the bottom, you just have a 4 plus 5. So you get 9 over 9, which divides out to get 1. Questions on the homework? The only thing we didn't have on here was something like this, negative 3 cubed, for instance. When you have a negative being raised to a power, it's the same as the multiple factor rule, because this means negative 3 times negative 3 times negative 3. So just looking at this, how many negatives are we going to have, class? 3. So since that's an odd number of negatives, my answer is going to be negative. Just as we would see it here with 3 negatives, we know there's going to be 3 of these negatives. And of course, 3 cubed is 27. So that would be my answer. But if this had been, for instance, squared, then I'd know there's going to be 2 negatives. So my answer would be a positive. And of course, 3 squared is 9. Of course, if the negative were not in the parentheses, we know it's just a 3 that's being squared to get 9. But we still have the negative. That would equal a negative 9. Questions on that? Questions on signed numbers? Yes, ma'am.
So just to clarify, because I know you just said that. So about the adding the inverse thingy, like when you have the problem like we've had before or something, I'm confused when you add the inverse thing, because when there's the parentheses in the thing, you have to change one sign, but don't you have to change the second?
Give me like a number from the homework, for instance. Like, for instance, number 46.
Yeah, like something like that.
Where it says negative 2 minus negative 40. Well, again, it says to subtract. I'm going to add the inverse. And that's where we got a positive 38, because now the signs are different. We subtract to get 38, keep the sign of the greater. Had it been like negative 2 minus 8. Well, that's a positive 8, but we're going to add, and now the inverse is a negative. Now the signs are the same. Add and keep the sign. Make sense? Good. Any other questions on this? Clear your desk, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. Clean sheet of paper, pencil, everything else away.
Okay, bye. Bye, side. I can't see it.
So she gave
Rough
me
life.
one.
Rough. All right. We will take quiz number 10. Quiz numero 10. Or however you say it. Is that right?
Technically, it's DS numero because the adjective comes first. But technically, because it's a predicate.
Okay, hush, Danielle. The quizzes are passed out. First last name at the top of your quiz along with today's date, which is 10/18/21. Pass those two back. Keep one. There we go. Take one, pass one back. There we go. We got this. 10/18/21 is today's date. Very straightforward. Find the answers. Use that blank paper as a cover sheet. When you finish, turn your quiz paper over and sit quietly until everyone is finished, or until I call time if someone's being slow. I didn't say anything about you. There's no reason you should be slow. You're going to be fast. Work. I'll close this one. Just a little bit longer to be finishing up. Once you're finished, if you want to ponder the deeper meaning of life, you may, or you can ponder what's on the bulletin or on the chalkboard. I should caution you, for those who are pondering the deeper meaning of life, therapy is not available today, so be careful. However, the Bible is always readily available, and that's better for therapy anyway. had 3 seconds to spare. Just wait. Go around behind the camera. All right. So let's consider, as we get ready to move forward, I suppose if you're watching on YouTube and need more time, you can pause the video, but several of you have had time to ponder this, since the deeper meaning of life for some of you is frightening. Just kidding. We have a great purpose in life. But anyway, coming back over here, what's the pattern that's developing in this number pattern here, Michael?
Adding 5.
Adding 5. You could say we're counting by 5s. That's how my kids would put it. They're in kindergarten and first grade respectively. But we know that counting by 5s just means adding 5. So what are my next 3 numbers, Michael?
25, 30, and 35.
How many thinking the same thing Michael just said? All right. What about on the next one? What's the pattern here, Glenn?
Times 2.
Times 2. Okay, so what are my next 3 numbers?
16, 32, 64.
There we go. How many thinking the same thing that Glenn just said? All right, let's get a little bit harder here. What's the pattern on the next one? Evie?
Subtract 3.
We're subtracting 3, right? So what are my next 3 numbers?
3, 0, negative 3.
Right, 3, 0, and negative 3. How many thinking the same thing that Evie just said? All right, what about the last one? What's the pattern here, Hayden?
Divide by 2.
Dividing by 2, right? And we're cutting the number in half is another way to think of it, right? And so what are the next 3 numbers?
6, 3, 1.5.
1.5. Or we could say 1.5, or we could say 3 halves, I suppose, as well. Right, but we see the numbers just getting cut in half or dividing by 2 each time. These number patterns are called sequences. Sequences. Turn to your textbooks to page 113. Now let's talk about sequences. I'm actually going to leave these up here for a minute. Let's talk a little bit about sequences. There are 2 basic types of sequences, and the first type of sequence is called an arithmetic sequence. Now, you're used to arithmetic. That's the name of the class, right? Arithmetic, the noun. Arithmetic puts the emphasis on a different syllable when used as an adjective. So an arithmetic sequence is one in which numbers are added to get to the next term. And by the way, you should know that every number in a sequence is called a term. So make sure you know that term. Term. Okay? Term. It's a number in a sequence. All right, and so in an arithmetic sequence, this, for instance, would be an arithmetic sequence. We are continually adding a 5, right? What about here? This is also an arithmetic sequence. Say, well, we weren't adding. Well, yes, we were. The way Evie put it, she said we're subtracting 3, but do we ever really subtract, class?
No.
We add the inverse. So instead of thinking of this as subtracting 3, though there's nothing wrong with thinking that way, mathematically the correct way to say we are technically adding a negative 3 each time. Mathematically it's the same thing, but it's the more correct way. So here we're adding a positive 5, here we're adding a negative 3. But they're both arithmetic sequences. Notice in this arithmetic sequence, the numbers get bigger, don't they? We'd call this an ascending arithmetic sequence. You see that example there in that little blue shaded box. If you continually add a positive value, you're going to get increasing numbers. By the way, theoretically, these sequences on page 113 go to what class?
Infinity.
Infinity, right? There is no end to an arithmetic sequence. Even a descending sequence, which is what we see here. An arithmetic descending sequence adds a negative value, right? And that negative value that continually gets added is going to take us down to negative infinity, in theory. Make sure you know this term as well, common difference. The positive 5 that's being added, or the negative 3 in this case that's being added, is called the common difference. Because you could think of it, what's the difference from one term to the next? Well, there's a difference of 5 between the terms. There's a difference of negative 3 between the terms. We call this the common difference. In this case, the negative 3. In this case, the positive 5. Notice the arithmetic sequence in the second blue shaded box. It goes 6, 11, 16, 21, and so forth, right? Well, to find the common difference, you simply subtract any term minus the previous. 11 minus 6 gives us a common difference of 5. So 5 is what would be added. But notice in the previous example of the descending sequence, or maybe take this one. If you take any term, 9, minus the previous term, 12, or add the inverse, notice it gives you a negative 3. Well, of course it gives you a negative. The common difference, of course, will be negative because it's a descending arithmetic sequence. Questions on the arithmetic sequence. A lot of terminology, but as far as the basic operation, pretty easy. Look at the yellow box. Notice the pattern. 90, 87, 84, 81. What's going on here, class? We're subtracting 3, or more accurately, we're adding a negative 3. So we would say that the negative 3 is our common difference. So the next term, we would simply add a negative 3 to get
78.
78. Then the next term, we'd add another negative 3 to get
75.
75, and so on and so forth. Does that make sense? Any questions on the arithmetic sequence? Seem pretty easy? Yes, ma'am.
So all of these different sequences, they can be used with positive or negative?
Right, positives or negatives. So positive number makes it ascending, getting bigger toward infinity. Negative common difference would make it get smaller toward negative infinity. All right, turn your textbooks to page 115 and do numbers 1 through 4. Number 1, part A, identify the relationship. In other words, the common difference. And part B, figure the next term. So first write what's the common difference, then what's the next term. Part A, what's the common difference? Part B, what's the next term in the arithmetic sequence? Evie's finished, Aubrey's finished, Hayden is finished, Michael's finished. Glenn's softball team is finished. Hayden has a plan. I was telling him before class, he's going to break everybody. Just kidding. He didn't tell me anything before class. I'm just picking on Hayden. Glenn. Picking on Hayden too. Whatever we seemed to be working last time, 0-0 tie through 3 innings, he held him at bay. You just didn't get any offense going, but
Yeah. We got a lot of
yes, defense was much better. Yeah.
About 4.
Okay, well, let's take a look at this together. Number 1, what is the common difference here, Lexi?
Plus 4.
Positive 4. You take any number in the sequence, subtract the previous. So 15 minus 11 would have given you a 4, or 11 minus 7 would have given you a 4, or 7 minus 3 would have given you a 4. So really you take your pick. Once you know the common difference is positive 4, you will add that value to the last number to get what next term in the sequence, Lexi?
Oh, we're supposed to do both.
Yeah, both part A and part B. So what's the common difference? What's the next number? And it is
19.
19. Good. Number 2, what is the common difference, Michael?
Adding a negative 2.
Negative 2, very good, because you take any number and subtract the previous, you come up with a negative 2. 26 minus 28 or plus negative 28. 28 minus 30 or plus negative 30. 30 minus 32 or plus negative 32 gives you a negative 2. So if we add a negative 2 to the last number, what is our next term in the sequence going to be?
24.
Positive 24 will be our next number in the sequence. What about number 3? What's the common difference, Glenn?
positive 11.
I'm sorry?
Positive 11.
It's not a positive, and the way you know it's not a positive is the numbers are getting smaller. Also, if you took any number, just pick the 59 for instance, and subtracted 70 from the 59, it would have given you not positive, but negative 11. Now again, practically speaking, you're subtracting 11, but if you want to think of it that way, also put the negative on there, right? So negative 11 should have been our common difference. You may have still gotten the same correct answer though. Positive 37 is still the next number in the sequence, the next term in the sequence, but negative 11 is our common difference. Again, anytime the numbers get smaller, negative common difference. If the numbers are getting bigger, it's ascending, positive common difference. Number 4, Danielle, if we take any two numbers, let's not take the first two because they're annoying. Let's take the middle two. Okay, take the 6 and subtract the previous number, 1, to get a common difference of 5. So that means that's what we're going to add to the last number. And if we add a 5 to the 11, we get 16. Very good. Just as in the previous case, if we add the negative 11 to the 48, we get 37. So subtract two numbers to get the common difference. Add that on to the last term to get the next term.
So A is positive 5.
A is positive 5, B is positive 16. And then we go 4 for 4 on these. Get them all. All right, any questions on arithmetic sequences now that you've had a chance to work some on your own? All right, let's talk about the next type of sequence. And here, the second sequence we did, Glenn said we had to, I think it was Glenn said we had to multiply by a 2. Here, Hayden said we had to divide by 2, and I kind of rephrased what he said. He said divide by 2. I said or take half of the number. Half of means multiplying by 1/2. And you'll remember that when we divided with fractions, we said we wouldn't really divide, we'd multiply by the reciprocal. So technically, one could argue that both of these are sequences that involve multiplication, right? Here multiplying by a 2, here multiplying by a 1/2. But they're both multiplication. These sequences are called geometric sequences. If you flip back to page 113, geometric sequences involve not adding a particular value, but here multiplying a particular value. So arithmetic, add, geometric, multiply. And this value that you multiply is called the common ratio. The common ratio. To figure the common ratio, you would take any number and divide it by the previous. 8 divided by 4 equals 2. That's my common ratio. That's what I multiply by to get the next number in each case. Here I would take any number, divide by the previous. Notice this comes out to a 1/2. So I multiply by half in each case. By the way, here's where it would have been easier to leave it as a 3/2. So when you multiply it by 1/2, class, you get 3/4. And then the next number, I multiply by a half again to get 3/8, right? And then 3/16, and then 3/32, and so on and so forth, right? So, you know, the sequence just keeps going and going and going. But notice the numbers getting smaller and smaller and smaller and smaller, aren't they? Closer and closer and closer to 0, but never quite reaching it. Here, the numbers, since you're multiplying by an integer as opposed to a fractional value, the numbers getting bigger and bigger and bigger and bigger, approaching infinity. And approaching much faster than they would in an arithmetic sequence, by the way, right? So numbers just getting bigger and bigger, smaller and smaller. These are called geometric sequences. And again, this number that you multiply by, whether it be a fraction, whether it be a whole number, or an integer, I guess we could say, is called the common ratio. Now, interestingly, since the common ratio is positive, notice all of my numbers have the same sign. Even if they'd start us with negatives here, right? Because when you divide a -2 by a -1, or a -4 by a -2, you still get +2, right? But if you multiply by a +2, they all have the same signs. And in this case, they're approaching negative infinity, right? But what if we had a -2 we multiplied by? Then this would have been a positive. But you multiply by a -2, it gives you a negative. Multiply by -2 gives you positive. The signs would end up alternating, wouldn't they, if we had a negative common ratio? I want you to make note of that there. It's that last statement on page 113. If you have a negative integer, signs will alternate. Terms alternate between positive and negative if the common ratio is negative. Notice it says since the common ratio is negative. Well, they were talking about a particular instance listed out there. But if the common ratio is negative, terms will alternate between positive and negative numbers. So we see those geometric sequences in the little blue box. If the common ratio is a -3, you have 1, -3, +9, -27. What would be the next number in that first blue box sequence, class? Multiply by another -3, you'd get?
-9.
What is 61?
Positive, carry the 2, 81, right? And then so, again, it's in the blue shaded box. But the next number, if you continue to multiply by a -3, you get a positive 81. Then if you multiply by another -3,
243.
negative 243, right? Or did I get the signs backwards? No, I got it right. Negative 243. And we see the signs just continue alternating here. So alternate numbers get bigger, really small, bouncing back on opposite ends of the number line. An arithmetic sequence won't do that. Look at the next example they have there. They've got 4. Then they're down to 2. Then they're down to 1. Notice what they're doing. They're cutting each number in half. That is to say, they're multiplying by a half, aren't they? So the next term would be a half. What would come after a half?
0.
No.
You're multiplying by another half.
2/4.
1/4, because 1 times 1 is 1 and 2 times 2 is 4. Multiply that by a half, what do you get?
1/8.
1/8. Then
1/16.
1/16.
1/32.
1/32.
164.
160, and they just keep getting smaller and smaller. But that happens with rational or fractional common ratios. Turn the page. So how do we find the common ratio? Well, like I say, take any number and divide it by the previous. 9 divided by -3. -3 is your common ratio. And we see that in that top blue shaded box. 2, 6. Okay, what's the pattern? Take 6 divided by 2 is 3. So keep multiplying by a 3. That's your common ratio. 18, 54. Multiply that by 3. 162. Multiply that by 3. 486. And we see the numbers get big very, very quickly. Look at the example problem in the yellow box. It says find the relationship and the next term for the geometric sequence. 12, 6, 3, 3 halves. What are they doing in each case?
Multiplying by 1.
Multiplying by a half. Again, take the 3 divided by 6 to get a half, or 6 divided by 12 to get a half. Find that common ratio. And then multiply everything by the half. 3 halves times a half gives 3/4 as the next term. Questions on geometric sequences? All right. Look over at page 115. I want you to do pages 115 to 116, numbers 5 through 8. 115 to 116, numbers 5 through 8. Identify the relationship, meaning the common ratio, and the next term in the sequence. Find the common ratio and the next term of each geometric sequence. All right, let's take a look at these. Back on page 115, number 5. What is the common ratio, Aubrey?
Multiply by 2.
2 is the common ratio, so therefore the next term in the geometric sequence should be
48.
48. Very good. Number 6. What's the common ratio, Evie? Number 6. What's the common ratio?
Divide by 3.
Divide by 3, but the common ratio is you multiply by the reciprocal, which would be 1/3. So the common ratio is 1/3, and if you multiply by 1/3, or practically speaking, divide by 3, you get 5 for your next term in the sequence. Number 7. What's the common ratio, Danielle? 6. And so the next number in the sequence, didn't get that far, help her, Michael?
1,296.
Yeah, it's a big one. 1,296 is the next term in the geometric sequence. Number 8, what's the common ratio, Hayden? -3. And so what's the next term in this alternating geometric sequence?
243.
Positive 243. Great job. Questions on 5 through 8? Yes, ma'am.
Back on like something like numbers 6 and 5. So I'm confused about like the 1
Okay, take any number in the sequence on number 6. Preferably
One.
easy number.
45 and 15.
Okay, no, other way around.
45 and
15 and 45. You take the one number and always divide by the previous. So if you take the 15, you have to divide it by the previous to get 1/3. Just as on number 5, take any number like 12, divide it by the previous to get 2. Does that make sense? So term divided by previous equals common ratio. That's in geometric. In arithmetic, term minus previous equals common difference. Does that make sense? But you're always dividing by previous or subtracting previous to get the common ratio or common difference, which is how you may end up with fractions or negatives in some cases. Good question. Good. Any other questions? All right, now let's mix it up. Okay, so on numbers 9 through 16 on the next page, they may be arithmetic or they may be geometric. You have to figure it out. So if it's arithmetic, find a common difference. If it's geometric, find a common ratio. Regardless of which one you find, also find the next term. So doing numbers 9 through 16, they're on page 116. You're first going to have to figure out, is it arithmetic or geometric? So you know whether you're finding a common ratio or common difference. Once you've found that, find the next term.
can figure out the pattern. Takes a little more thought.
Take about 2 more minutes to work on 9 through 16. If you're finished early, we still have about 1 more minute. If you're finished early, look at number 17. It's not an arithmetic sequence or a geometric sequence. There's a different pattern. See if you can figure out the pattern if you're done early. We'll talk about those in just a few moments. All right, pencils down. Pencils down, even if you're not finished. Number 9. Are we multiplying something? Are we adding something? What type of sequence was this? Arithmetic or geometric? Danielle?
This one was arithmetic.
Arithmetic, good. We're definitely not multiplying anything. What are we adding to go from one term to the next?
Positive.
A positive 4. That's your common difference. So the next number in the sequence should be -8. Perfect on number 9. Great job, Danielle. Number 10. Is this geometric or is it arithmetic? Michael?
Arithmetic.
Arithmetic. What are we adding to go from one term to the next?
-7.
-7. Very good is our common difference. So what's the next number?
-24.
-24. Perfect on number 10. Great job, Michael. Number 11, Hayden. Is this arithmetic or geometric?
Geometric.
That's pretty easy to spot because you have this huge gap between the first two and a much smaller gap between the next two. We know it's not arithmetic, got to be geometric, but what's the common ratio? 1/4. So when you multiply by 1/4, what's the final term? Or the next term, I should say. There's no such thing as a final term.
3/4.
Really close. Class? We multiply -3 times the fourth, -3/4. There we go, -3/4. By the way, notice all of them are negative because the common ratio is a positive value. Number 12 is kind of stupid. Number 12, arithmetic or geometric, Aubrey? Geometric. We're not adding something, we're multiplying. And what are we multiplying? -1. That's our common ratio. So what's the next term? -2. It just keeps -2, +2, -2, +2 the whole time. Let's see, alternating sequence there. Number 13. Ugh. What kind of sequence is this, Evie?
Geometric.
Are we multiplying something? Doesn't look like it. Usually the geometric's pretty easy to spot, so it's arithmetic. What are we adding in each case?
I'll skip this one.
Oh, you skipped this one. Oh, for shame. Glenn, did you skip this one? Brave man. Good. Okay. Did you spot that it was arithmetic? All right. What's the common difference? Well, if it were a half, we'd go from 2.5 to 3, 3.5, 4, 4.5, 5, and so forth. And it's not getting bigger, it's getting smaller. So it's got to be, whatever our answer is, it's got to be a negative, right? Because it's getting smaller by how much? We go from 2.5 to 2 1/4 to just 2 to 1 3/4. And I'm picturing those circles, you know, that we had in elementary school. Right, it's negative a fourth is our common difference. So if we keep going negative a fourth, what's the next term?
2.
Well, that'd be if we added a fourth, it would be 2, right? But we're putting negative a fourth, so we're putting a negative 1/4 with a 1 3/4 to get 1 2/4, right? Which, or in other words, reduce that to 1.5. Did anyone get that? Negative a fourth with 1.5. Great job, gentlemen. That was a challenging one. Now, that doesn't mean we skip it, but maybe we come back to it last, right? We skip it and come back to it. We certainly don't skip it permanently. So back to Evie, since we don't skip her permanently either. Number 14, geometric or arithmetic?
Geometric.
Geometric. And what are we multiplying? What's our common ratio?
1/5.
1/5. We can think of dividing by 5 practically, but that becomes a 1/5, which means our next term is going to be what? 4/5. Great job on that one. Number 15, arithmetic or geometric, Lexi?
Geometric.
Geometric. What are we multiplying by?
1 times 1/5.
Number 15?
No, number 15. Times negative 1/2.
Negative a half, right? We're cutting each number in half, but we're also changing the sign. So negative a half. So what's the next term in the geometric sequence? Well, if we multiply by negative a half, right? 4 times negative half, or cut it in half and change the sign, negative 2 would be our next term in the sequence. Number 16 is kind of weird. Now, I'm glad they didn't reduce these, because that could have really made life hard. If they'd written, listen, 1/3, 5/6, 4/3, 11/6, that would be evil. At least they showed the common denominator, right? 2 6, 5 6, 8 6, 11/6. Is this arithmetic or geometric, anyone? Arithmetic, what are we adding?
4.
3/6, 1/2, right? But think of it as 3/6. So what's the next term in the sequence? 14 is 6. That one's just kind of weird, but at least they had a common denominator for you. Anyone go 8 for 8 by any chance? Wow, some of you, how about 7 for 8? Just missed one. Okay, 6 for 8, just missed a couple. All right, questions on these? All right, we did not have time to get as far as I wanted to here, so we'll have to talk about those weird ones. He really wants to talk about it, don't you? Number 17?
Yeah, I figured out all of them except for 19.
All right, tell you what, I'll run through it real quick. Stay with me, and I'll give you a pass to get your next class. All right, so number 17, 4 to 5, you add 1. 5 to 7, add 2. 7 to 10, add 3. So what are we going to have to do to get to the next term? Add 4 to get 14. Then we'd have to add 5 to get 19 and so forth. Number 18, we multiply by 4. And then we don't multiply by 4, we multiply by
16.
4 squared, which is 16.
And then
So then we're going to have to multiply by 4 cubed, which is 64. And we multiply by 4 cubed, that's going to be a really big number. No, that's not what we're squaring each number, right? We got 4, and then we squared to get 16. We squared to get 256, actually.
256 times 256
is what?
I got 165,536.
Close. 65,536, not 106. But I think you misread a 1.
Oh yeah,
All right. So we just square each number. 4 squared is 16. 16 squared is 256. 256 squared gives you 65,536. That's obnoxious. Number 19 is similar, but we're not squaring each number. We're doing consecutive cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. What would be the next number? 4 cubed, right? Which would be, figure it out real quick. 4, 4, 4.
64.
64. Then the next number would have to be 5 cubed, which is
64 times 64.
no, 5 cubed. So it's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed would come next. 125 and so forth. Then let's see, number 20. So we're adding a 1, then we're adding a 3, then we're adding a 5. So we're adding odd numbers. So then we'd have to add 7 to get 20. Then we'd have to add 9 to get 29. Anyway, those are fun. Tell you what, your homework is to do 1 through 21 on the homework, pages 116 to 117, but 9 and 10 are optional, because 9 and 10 are weird. Okay, so if you want to tackle 9 and 10, more power to you. If you're like, I ain't got time for this, then you don't have to do 9 and 10. But page 116 to 117, the homework, numbers 1 through 21, but you can skip 9 and 10 if you want to. Have a wonderful rest of your day. You are dismissed.
We can just clap.